2 or 3 kilometers in size, creating this feature. This feature is right at the edge of the A-ring. So it was discovered in 2013. Its discoverer, Carl Murray, discovered it on his mother-in-law's birthday, so he nicknamed it Peggy after her. So this tiny object that's here creating this feature, Peggy, we've been watching for her ever since. She comes and goes. We're wondering, will she break free of the rings and become a moon in her own right? Or will she be torn apart and jostled by the other particles in the rings and disappear? So far she's still there. We're going to keep watching for her through the end of the Cassini mission. We're kind of rooting for her by now because she's been around for a few years. Moving on to Saturn, one very interesting event happened at Saturn. A giant storm developed toward the end of 2010. This storm grew so huge, it was a giant vortex, and that vortex swirled off this huge tail. The tail of the storm wrapped itself around the planet. There was another vortex on the other end, kind of like a hurricane. When these two vortices merged, that marked the end of the storm. A tremendous amount of energy was released in this storm at Saturn, and typically these storms happen about once every 30 years. And so this was the 5th time we've seen a giant storm like this at Saturn. But what was unique is this storm was early. It had only been 20 years and watch it. And so we watched it, as did ground-based observers. It lasted about 9 months and started to fade. Now this is in the visible. If you look toward the near infrared, you see deeper into the atmosphere. The colors in this view, if it's white or yellow, that's high up in the atmosphere. Green is also high up. That's the center of the storm. And then the oranges and the reds are looking deeper. So we're basically getting a profile of what that storm looked like and how those clouds behaved. And we can model that and perhaps use it as an analogy to storms in the Earth's atmosphere. Now looking at some of the longest infrared wavelengths, the thermal infrared, turns out that the storm was in the lower atmosphere of Saturn, the troposphere. But when those two spots merged, it released a tremendous amount of energy, kind of like a giant burp. And here up in the stratosphere is a large, very hot feature. And this feature persisted for a couple of years and has slowly cooled. So a very dynamic and active Saturn, at least in that time period. Now Saturn has a very interesting feature at its north pole. Here's that feature. You're looking right down at the north pole of Saturn. That feature is a 6-sided jet stream called the hexagon. The Voyager spacecraft first saw this feature in the 1980s, and it was still here when Cassini arrived. You can see the pinkish clouds. This is a false color view, rotating around, and they go faster the closer you get directly to the North Pole. And at the North Pole, there's a giant hurricane. And this hurricane is about 50 times larger than a typical Earth hurricane, blowing about 340 miles an hour. And finally, before I pass it over to Earl, this is a view of the changing seasons. In fact, Saturn's shadow on the rings you can think of as a giant sundial. And this picture taken back in April of 2016, you can see that the shadow of Saturn goes out just past the Cassini division. At solstice, that shadow will pull in until it's about in the middle of the B ring. And so as that shadow pulls in, so will Cassini's time shorten at Saturn. With that, I'd like to turn it over to Earl to talk about the grand finale.
So how does Cassini follow that? How do I follow that? I want to go first next time. You know, one of the things about Cassini is it always trumps itself. You know, as we keep finding, you know, one year we announce a subsurface ocean, next year we announce a global ocean. So it keeps building and building and building. And then you look at the last 12 years, and how do we do something even more spectacular in our final year? Well, I'm going to show you at least the potential for that. But before we do that, I want to this is September 14th, 2017. It's about 2 o'clock in the afternoon here in Pasadena. And Cassini has just wrapped up a 30-hour or so observing session. The recorders are packed full of images and data, fields and particles data. And so now it's time for Cassini to turn back to Earth and begin to play those back. So this is a speed. slow speed version of the last of these periods. So Cassini's going to be working on this for about 10 hours. The DSN is going to be receiving all this data. We are going to be streaming these back, and as soon as we see them, you'll see them. Some spectacular images of the poles and of the rings as we come in. And then when the SSRs, the solid state recorders, are empty, it'll be about 10 hours. Cassini's going to reconfigure for the periapsis here at Saturn. I want to make sure So we've done that 292 times over the last 7 years. Periapsis at Saturn is pretty routine, but not this one. This one is absolutely unique because it's Cassini's last. 3 days before this event, Cassini had a close encounter with Titan. Titan gave it a little gravitational nudge, and that nudge has pretty much sealed Cassini's fate. As a matter of fact, it's not coming out of this periapsis. It's moved the periapsis, the closest approach distance, inside the capture radius of the Saturn's atmosphere. And so Cassini, this one, is going to reconfigure itself so that it doesn't put the data on the recorders. It's going to put everything out on the pipe as quick as it can. So the minute you see, now it's every second of this data is going to be coming back to the Earth. And unfortunately, Cassini is going to be going 77,000 miles per hour. You can get her about 20 minutes at that speed. So what's going to happen? It's going to happen we are going to have every piece of data streaming back down. We're going to answer some of the fundamental questions about Saturn's atmosphere, but it's not going to be very fast. It's not going to be very long. At 77,000 miles per hour, Cassini is going to be going in with its antenna pointing to the Earth, but the atmosphere is going to quickly overpower its ability to point. It just doesn't have that kind of control. It's going to push it off, and then we'll lose comm. It will essentially disappear from our monitors, and about 3 or 4 minutes later, that speed and the density of Saturn's atmosphere will vaporize Cassini, and it is over. One of the most spectacular missions to leave Earth, a discovery machine like you will never see, and it's going to be done. Are you doing that? I mean, the first thing, did you guys ask anybody something that is rewritten? Science programs, read missions. You ask, just destroy it? I'll explain why we think that's a good idea. In order to do that, I got to go back a little ways. So back to 2009. Linda told you about the prime mission and the extended missions. We got to Saturn in 2004, right? We had a 4-year mission, but we didn't have any end. There was no end game planned. But we got to the end of that mission, realized we had an incredibly good spacecraft, lots of propellant, so we went for another 2 years. About midway through that second mission, 2009, said, geez, all subsystems are great. This system is wonderful. We've got a lot of gas in the tank. Let's do something else. So what? What's next? And we actually got a lot of studies done. You know, there's a lot of opportunities at this point with all the subsystems going. We could have left Saturn. We could have gone off to the Centaur asteroids and turned ourselves into, reconfigured, repurposed Cassini as an asteroid mission. We could have, believe it or not, left Saturn and gone to Jupiter, or gone out to Uranus, or gone out to Neptune. Now, I got to say, this was a 40-year cruise, so, you know, I mean, it would have been a long cruise, but, you know, look where Voyager is. It was possible. We could have gone back to Jupiter. That actually is an image we took on our way out, and we could have gone back and spent, you know, the same set of resources on Jupiter as we did on Saturn. Uranus is also a possibility, or more of Saturn. Well, you know, this is kind of a no-brainer. I mean, we have the surface. Saturn is just incredible. You couldn't have added a dynamic environment. You've got the rings, you've got the planet, you've got the icy satellite, and Enceladus, little prebiotic worlds on their own. And Cassini's still unwrapping this. So it's really not hard to figure, okay, we got to stay to the chase real quick. Nah, we're not going there. Nah, we're not catch. If you want to stay at Saturn, there's some rules. And they are, we call it planetary protection, but the real essence of this is you've got to protect Saturn's ocean worlds. Cassini is essentially a victim of her own discoveries. You